Hello everyone and welcome to Brain Blitz Audios. Today, we're going to be starting off a new segment titled Oxford Math. Now, Oxford Math stands for the Oxford Mathematical Admissions Test, and this is basically an admissions test for students attempting to pursue degrees in mathematics, physics, computer science, etc. So, we're going to be looking at some previous year questions of the test, and we're going to be particularly looking at tests from 2021 and finding out what the correct solution for our questions are. So let's start off. A regular dodecagon is a 12-sided polygon with all sides the same length and all internal angles equal. If I construct a regular dodecagon by connecting 12 equally sized points on a circle of radius 1, then we need to find out the area of this polygon. So we have a dodecagon. 12 sides also means that it would have 12 vertices, and all sides are of the same length, and all internal angles are equal because we're using a regular figure. Now, we are constructing a regular dodecagon by connecting 12 equally spaced points on a circle, and its radius is 1. So this is what that figure would look like. So its radius is going to be 1, and if we look at it, we can essentially construct 12 isosceles triangles, which is how we're going to solve the question. Because here we need to find the area of the polygon. The best way to do that is by dividing your polygon into triangles or squares or any other smaller figure by which you can find out the area and then composite that into a larger area. So for a dodecagon, it's got 12 sides, and this dodecagon is in a circle of radius 1, and all of its vertices are on the circle. So which means that the isosceles triangles present in the dodecagon are 12 in number, and all of them have two sides which have the length equal to the radius of the circle. Now, we know that all internal angles of a regular dodecagon are equal. So in order to find the angle between two radii, we're going to divide the total internal angle, that is 360, and divide that by the number of radii, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 360 divided by 12 would give us 30 degrees. So the angle between any two radii is 30 degrees. Now, in order to find out the area of the polygon, now we have 12 triangles in the polygon. Now that means the area of the polygon would turn out to be 12 times area of one single triangle. Now, area of a triangle with the formula that we normally know of is 12 times half base into height. But here we run into a problem. We're given isosceles triangles. The equal sides, their length is equal to the radius of the circle, which is 1. However, we're not given anything related to the base and the height. So we need to find out how to express the area of a triangle in terms of two sides. So let's take any triangle. Let's construct a separate scenario in a triangle ABC. We've got 3 vertices ABC. We've got 3 sides ABC. We've got an angle. We've got a height h, which is present, which connects vertex A to the line BC. So this is the height of the triangle. Now, we also have an angle theta, which is basically angle ACB. Now, the area of this triangle can be taken as half base times height, and base here is remarked as B. Now, when we use trigonometry, we can see that sine of the angle theta would be equal to the opposite side of the angle, that's h, divided by the hypotenuse of the triangle, which consists of the height h, which in this case is A. So let's consider that the point D is where the height meets the line BC. So in triangle ADC, sine theta is equal to h over A. So when we write that down, we can see that A sine theta is equal to the height h. We're going to plug that in here to the area of the triangle. So now the area of the triangle turns out to be half AB sine theta. So basically, using the sine function, we've now converted the area of a triangle into from half base times height into half of two sides times sine theta, where theta is the angle between the two sides. So this is our equation 2. Now we will apply equation 2 to equation 1. Now if you remember, our equation 1 was the total area of the polygon is 12 times half BH. So the total area of the polygon is equal to 12 times half into base into height. Now that particular formula in the brackets would be changed to half AB sine theta, where A and B are two sides of a triangle, and theta is the angle which is subtended by those two sides. So if you look at any triangle here, the theta is the angle here, which is subtended at the center, and that theta is equal to 30 degrees. We know that. Moreover, we know that in the isosceles triangle, the two radii which form the two sides are equal to 1. So therefore, when we plug in our values, since A equals B equals 1 and theta equals 30, our total area would now be equal to 12 times half into 1 into 1 into sine of 30. Now sine 30, its value is 1 by 2. So the total area of the polygon would now be equal to 12 times half times 1 is 1 times half. So 1 by 2 into 1 by 2 would give us 1 by 4, and that multiplied by 1 would give you the same value. So basically the total area is 12 divided by 4, which is equal to 3. So area of the polygon is actually equal to 3. Now if you look at our options, you can see that the only option that corresponds to it is option E. So option E turns out to be the right option in this particular scenario. So the idea is we've got a dodecagon subtended in a circle, which is present inside a circle. All of its vertices are along the circumference of the circle. We know the radius of the circle. We just need to find out the internal angle subtended by the radii. We also need to use the formula for the area of the triangle based on the sine function, and using that we can basically calculate the entire area of the polygon which is subtended in the circle, which in this particular scenario turns out to be 3. Option E, 3, is the right answer to this question. Now let's move on to the next question. The positive number a satisfies the given equation if the value of a is one of the 5 options. Now the given equation that we have is integral 0 to a under root of x plus x squared the whole dx equals 5. Now, in order to solve this particular question, we are going to have to do a bit of integration. So, the original equation that we have, integral 0 to a under root of x plus x squared dx, gives you 5. So, we're going to split the integral and convert the under root of x into x raised to 1 by 2. So right now the equation would be integral 0 to a x raised to 1 by 2 dx plus integral 0 to a x squared dx, and the right hand side would still remain 5. Now, if you've learned integration, then integral x raised to n dx is actually equal to x raised to n plus 1 over n plus 1. And if you're doing actual integration, then you need to add a constant c to it, but we don't have to do it here. So what we're going to do is we're going to use this particular formula in order to solve both integration steps. So the first step is integral 0 to a x raised to half dx. So that, if we erase this particular integral sign, so that particular step is now going to be equal to x raised to half plus 1 over half plus 1. And these are within the limits 0 to a. Now if we look at the second part, the second integral that says integral 0 to a x squared dx, so that's the straightforward application of integral x raised to n dx. So that will now become x squared plus 1 over 2 plus 1, and the limits are from 0 to a. The right hand side still remains 5. Now x raised to half plus 1 is x raised to 3 by 2, and the variable would be within the limits from 0 to a. 1 by 2 plus 1 is actually equal to 3 by 2, and it's still in the denominator, which is why we wrote 1 over 3 by 2. On the other side, we've got 1 by 3 outside, and then inside the bracket we've got x cubed with limits from 0 to a. The right hand side still remains 5. Now 1 over 3 by 2 gives you 2 by 3, and we're going to apply the limits here. So the upper limit is a, so it'll be a raised to 3 by 2 minus the lower limit is 0, so 0 raised to 3 by 2, which is basically 0. Similarly, 1 by 3 times a cubed minus 0 cubed, which is again equal to 0. The right hand side remains 5. Now remember, on both terms on the left hand side we've got 3 in the denominator, so in order to avoid the fraction it'll be a good idea to multiply both sides by 3. So multiply both sides by 3. Now we will get the equation 2a raised to 3 by 2 plus a cubed would give us 5 times 3, that is 15. Now a cubed is the highest integral, a raised to 3 by 2 is the under root of that, so if you were to take a raised to 3 by 2 as x, then a cubed would be x squared. So our equation here would be a cubed plus 2a raised to 3 by 2 minus 15 is equal to 0. So we can now basically solve it like a quadratic equation. Now we're going to use splitting the middle term here. The last term is 15. 15, you can split it to 5 and 3, and 5 minus 3 would give us 2. So therefore, when we use splitting the middle term, the equation becomes a cubed plus 5a raised to 3 by 2, and then we've got minus instead of plus, so 5 minus 3 would give us 2, so it'll be minus 3a raised to 3 by 2 minus 15, which is equal to 0. So then it'll be a raised to 3 by 2, that's taken outside, and then inside it'll be a raised to 3 by 2 plus 5. Then on the other side it'll be minus 3 times a raised to 3 by 2 plus 5, which is equal to 0. So the two equations that we get are a raised to 3 by 2 minus 3 and a raised to 3 by 2 plus 5. So the possible values of a raised to 3 by 2 will be equal to minus 5 or 3. However, when we did the limits for the particular equation, for the particular integral, the limits are from 0 to a. And the question also says that a is a positive number. So therefore, a has to be greater than 0. Now that means the only equation of the two of these that's real is a raised to 3 by 2 minus 3 equals 0. That means the value of a raised to 3 by 2 is equal to 3, since a is greater than 0. Now a raised to 3 by 2 is equal to 3. We need to find the value of the positive integer a. Well, we can use a raised to m whole raised to n equals to a raised to mn in order to solve our equation from here. So since we've got 3 by 2, we can just multiply that with 2 by 3. So a raised to 3 by 2 whole raised to 2 by 3 would give you 3 raised to 2 by 3. So 3 and 2 gets cancelled. The left-hand side is a, the positive integer, the positive number, and the right-hand side is our answer for a, which is 3 raised to 2 by 3. So 3 raised to 2 by 3 turns out to be the right answer. Now, if you look at our options, you can see that option C, a is equal to 3 raised to 2 by 3, is the answer. So basically, we did integration with limits, and then once we got the integrated equation, we then proceeded to solve it like a quadratic equation by splitting the middle term, and then finally, using the condition that a has to be a positive number, find the value of a raised to 3 by 2, and then from there find the value of a by using the exponent's law. So that's how we got C, a equals to 3 raised to 2 by 3. So we hope you found this episode interesting. In order to learn more about questions from Oxford Math or any other examinations or other types of content, please don't forget to subscribe to Brain Blitz Audios. So you can also hit the bell icon, which is present down below, in order to get the latest updates from us. So until the next webisode, take care, stay safe, bye-bye for now.